Hello everyone, I welcome all of you for this IGBC exam preparation course. Myself Sarunan J. Bharati from Carbon Figure Academy. In this video, we will be talking about Module 5, Water Balance. So water balance refers to equilibrium between the water consumed and the water replenished within the building site through the strategies like rainwater harvesting, wastewater recycling, and efficient fixtures to minimize external water dependency. So in terms of an equation, we can have that water balance as water input is equal to water output plus the change in storage, right? So what are the input scenarios and output scenarios? These are the things. So in case of input, we majorly have the municipal supply, and additionally we have rainwater harvesting, and additionally we may have some quantum of water which are recycled, right? So in case of output, so as a major output contribution, domestic consumption, we use, right? And which means personal use like drinking, cooking, all those things. Then we use it for irrigation, some quantity goes there. Then as some quantity goes for the HVAC purpose, right? And some quantity goes as wastewater discharge, that is where the recycled component may come. And finally we may have some evaporation loss which is out of our control, right? So these are the different elements or components of a typical water balance calculation, right? So in case of domestic consumption, that is where we are having that full-time equivalents 8 hours per day. And for irrigation, typically the thumb rule is used is 6 liters per meter square, right? So that is how it is worked out. Then in case of wastewater discharge, again we have a thumb rule like out of supplied water, 80% goes to the wastewater. Like, so if you have 100 liters supplied, 80 liters goes as wastewater, right? So in case of HVAC, so we have again a typical formula like you have to consider evaporation loss plus blowdown loss plus drift loss. So I don't want to explain in detail about what these are meant to be. We may have a separate module about these HVAC and mechanical related systems separately, so we may discuss these things there. But this particular model is very short and simple, gives you a typical idea of how a water balance may look like and how the calculation may goes. So in case if you are going for an IGBC certification, so they may provide a detailed calculation steps which are required to show as a evidence for your water balance arrival, right? So this is a typical introductory stuff. So in case of one more thing I would like to clarify here, from exam point of view, you will not have any calculation kind of questions at all. So IGBC AP, the exam will try to testify your understanding rather than applying, right? So in case of applying, that's what you are going to do with the projects, but from the exam point of view, they won't ask any numerical based questions. So it would be all about conceptual based questions only, right? So you don't need to worry about the numbers here. So this is a typical water balance sheet may look like. So I just generated it with the help of ChatGPT. So please bear with it if you find any discrepancy with the numbers, double the times, triple the times it may be there. For appearance I'm telling. So in the left side we have a case, in the right side we have a case. So it would be like how a positive value, how a negative value may come in a typical water balance sheet, right? So let's take the left side one. So we have a scenario like there are certain water input goes and the water output goes, and typical storage change happens, right? So in water input scenario, we have municipal supply 5,000 liters per month, right? So typically this kind of water audit, water balance audit is done annual basis for entire year. What is the input output storage difference? That's how. It's not done based on monthly or weekly kind of scenarios. It's for annual scenarios. So accordingly the calculation should go on, right? So let's talk about that input parameters. Rainwater harvesting, we have 50,000 liters per year. That another assumption, right? So assumption, it should be a valid assumption based on your location and typical meteorological statistics and rainwater, average rainwater for that particular area. So based on that particular number should be arrived. So for example, here it is 50,000 liters per year, right? So it is like some certain description is there. Increased collection during 4 monsoon months, because we are about to account a serious segment in the year, in a given year, where more and more amount of rainfall is being expected, right? So okay, that is the value liters per year, 50,000 from rainwater harvesting. So it's a incoming, right? Then municipal supply is also again incoming. So how the municipal supply is there? 5,000 liters per month for 12 months, right? So it is like 60,000, right? Then recycled water. So out of that municipal supply, we tend to generate 80% as wastewater, right? So out of that wastewater, we are trying to provide some recycling option and all with either mechanical or phytoremediation or whatever the combinations may be. So out of which we generate recycled water as 3,000 liters per month for 12 months. So 36,000 liters per year. So now you just add up all these together, so for a given year, total water incoming, is like 1,46,000 liters per year, right? Now let's talk about water output, the usage, right? Domestic consumption, 6,000 liters per month for 12 months, right? So how this domestic consumption can be worked out? That's what we mentioned, that full-time equivalents in the previous module. We can see, we mentioned that yes, total potable water consumption divided by total number of occupants. So that will give you specific water consumption. So this kind of equation you don't need to worry about in case of a real project. The equation would be provided by the IGBC, that the particular green building framework guidelines, they would be providing the equations. You just need to get the relevant data and you just need to apply there, right? So domestic consumption, if it is a 6,000 liters per month for 12 months, means it is 72,000 liters. Then for irrigation and HVAC, around 3,500 liters per month for 12 months, it is 42,000 liters. Then for wastewater discharge, which means after recycling you are letting it out, right? 2,000 liters per month for 12 months, 24,000 liters. Evaporation loss, so 300 liters per month for 12 months, so it is 3,600 liters. So total water outgoing is like 1,41,600, so which is like lesser than total water incoming. So obviously what would happen in when you want to work out the storage, right? So here the water input is equal to water output plus the change in storage, right? That the delta. So how that delta is arrived? Total input minus total output, that is the change in storage delta. So you can able to see input minus output. Input is 1,46,000, output is 1,41,600. So we have like 4,400 liters per year is saved. So initial storage water available in the tank in the starting point of the calculation period, 10,000 liters, and final storage is like initial storage plus the delta value, so 14,400 liters. So which also indicates like, so you have a surplus water in your water balance. So on the other hand, in the right side example, we have a similar kind of values for water input and output. So in input, we arrive at like 1,40,000, and in output, we arrive at 1,74,000. So where the difference happening, irrigation and HVAC, more amount of scenarios happened. Then wastewater discharge, more amount of wastewater is being discharged than the recycling kind of thing. Recycled water is drastically reduced. Then municipal supply is being dependent more, and rainwater harvesting again is very, very less. So what it leads ultimately, the change in storage is being more, like total input minus total output. You just see total input is 1,40,000, whereas total output is 1,74,000. So which leads this particular system to negative value. So what does that negative value indicate? So it is like initial storage you have 10,000 liters, but in final storage you have minus 24,000 liters, which means deficit, right? So it is like you keep on depending on the municipal supply, external supply, and you spend more amount than how much amount of water got replenished within your system, right? So you had the opportunity for recycled water and you had the opportunity for rainwater harvesting. So for those two parameters you didn't work properly, so the dependency become more, and eventually you ended up consuming more. So here in water balance status, you can able to see it's a deficit, right? So this is how a typical water balance sheet and its working out would look like. So this is like a summary. So for each input you have a individual or dedicated formula how that has to be arrived, what are all the assumptions can be made. So it is like, as I mentioned, it will be provided in the IGBC green building framework guidelines itself. So lot of framework guidelines are there from IGBC. So around 25 plus building typologies are there. So which one you want to prefer, which means in case of your project, accordingly the relevant guidelines you got to follow. So under each element they would provide how it has to be arrived. So with respect to the formula, description of the formula, everything. So very actual appearance of a typical water balance sheet would very complex and would full of numbers, but these two boxes are like the summary, right? So just for you to have an understanding, so how a typical water balance would look like. So in the next module, we will be talking about the further concepts, and I would like to add upon here in our each module video, if you find go through that video description box, you can able to see module wise quiz link is there. So it is for your revision purpose. So once you watch the video, you just go down and check into the description box and click that description quiz link, and it will lead you to a Google form based quiz link where you can simply put your name and attempt all the questions, and once you submit, it will show up how many are correct, how many are wrong. So you can just self evaluate your understanding then and there, right? So in all the modules from module 1 till this module 5, the quiz link will be there, and it will be always obviously will be there for the further videos also. And one more thing, once all the modules are completed, I will post a separate module for mock exam guidelines, and with there in the description box in that video you will find at least a couple of mock exam links, so that you can fix a time, once you complete going through all the videos once again, and you can test yourself with the typical mock exams of IGBC AP, so that will give you kind of confidence in which section you want to work more, or in which section you want to refine your understanding, how to answer, how the question should be read. So all those things will be there. So out of all the modules, I will post a dedicated module or dedicated video for exam guidelines preparation and mock exam, right? Thank you.